Good afternoon, ladies and gentlemen. I'm Tony Woolridge, and I'm here representing Rhino Asphalt Solutions. Now, those of you who don't know us as a company, we're established in the year 2000. We cover the whole of the UK. We're specialists in highway maintenance. Last year we had a turnover of 10.5 million. And this afternoon I'll be talking to you a little bit about crack repairs. So why do crack repairs matter? The alarm survey this year stated that 52% of the local authority road network has less than 15 years of structural life remaining. And there's much talk about potholes and the prevention of potholes, and cracks are an early sign of surface deterioration, which often lead to potholes. So crack repairs will prevent potholes by reducing the ingress of water and reduce the amount of maintenance costs overall. Budgets are tight, with an estimated 17 billion backlog in carriageway repairs. Local authorities face increasing pressure to do more with less. Full resurfacing is expensive and isn't always the answer. It's disruptive and often unnecessary for early stage cracking. Crack repairs as a solution are a targeted and cost-effective way of treating cracks and reducing the ingress of water, which is a major cause of potholes. They're minimally disruptive and can be ready for traffic within hours at a fraction of the cost of resurfacing, and can extend the asset life for between 5 and 10 years, depending on condition and asset usage. Identification is key to understanding how to repair cracks. Here's a few examples of the type of cracking you might find. On the far left-hand side in your photo there, you'll see multiple cracking, followed by failed repairs such as overbanding, ravelling of surface joints, reflective cracking caused by concrete subbase, and hairline cracking, which is where it all starts. So what causes cracking? Well, to effectively repair a crack, it's important to understand the mechanism. Thermal cracks often result from, but not exclusively, from an overlaid concrete subbase. And the name reflection is the mirroring of the bay pattern underneath. Thermal expansion and contraction of the underlying pavement, such as shrinkage of clay, effectively tears the upper layer of the asphalt. And the action of this cracking then allows the ingress of water. And this type of cracking will usually start at the bottom and migrate through to the surface. Traffic-induced cracking, this is sometimes called fatigue cracking, and this will be caused by a number of factors, including age hardening of the asphalt, movement of the subgrade, such as rocking of concrete bays, or settlement of the subgrade. The action of traffic moving pavement exceeds the capability of the asphalt to remain flexible, and cracks form. Thermally induced or tension cracking occurs when warping stress in the base layers of the asphalt are transmitted through to the upper layer of the surface. Typically, this is most likely in spring and autumn, where there's rapid changes in temperature. In this instance, cracking will typically occur at the top of the asphalt layer and work its way downwards. In 2010, the BBA formed a specialist group to understand how to specify the repair of cracks, and how this could be specified and certified. In the top left of your image there, you'll see simple overbanding, and this is for single cracks of up to 5 millimeters wide, which can then be treated with a simple overband repair of up to 40 millimeters wide. The top right image shows a fill and overband treatment, And this is for a single crack of up to 40 millimeters wide, with a maximum band repair of 200 millimeters wide. In the bottom left, you'll see a single crack, an inlaid crack repair. Now, this is where the surface is milled out and the repair is inserted into the carriageway. And on the bottom right, you'll see a multiple repair where there's multiple cracking, and it's the same treatment with the inlaid treatment. This document also describes the type of materials to be used, whether they're high or low modulus. So what's that? High or low modulus? Well, is the crack moving, for instance? If it's a concrete subbase, then yes, the crack will be moving because of thermal expansion and contraction, in which case you'd be selecting a low modulus material. Alternatively, if it's something like a ravelled lane joint, it's likely that it'll be no, in which case you'll be selecting a high modulus material, which is a stiffer material and can withstand a lot more wheel tracking. So how do I specify a crack repair? Well, initially it needs to be a BBA HAPAS approved system or a comparable certified system. The repair width. Now, this is the width of repair that's needed to treat the crack, not the crack width. We often get asked to repair a certain crack width, but that's not really much use to us. We need to know how wide the crack needs to be. Also, the repair depth. How deep do we need to repair that crack? It may be 20 or 40 millimeters deep. Then lastly, what type of material? Will it be a high or low modulus material, flexible or a high modulus repair? So this is how we do it. So you see there on your left, there's an image there of one of our small road planers creating a recess in the surface, which is then cleaned and swept. We then clean with hot compressed air and apply the material to the recess. In this case, it's a joint master repair. That's finished flush with the surrounding road surface. We then dress it with a high PSV aggregate and then sweep the remaining excess aggregate from the surface. And this is the finished repair. So you can see the before and after there with the water sitting in the cracked repair, into the crack, and then the final finished repair. Fill and overband systems slightly different. They're a surface applied treatment, and that will be either a cold or a hot applied resin. They're usually a single or a two-part system, but basically they fill and seal the road surface. They have to have a skid-resistant finish. You imagine I'm a motorcyclist, so I'm often riding along roads where you want to know that the road surface underneath you is safe, and having a skid-resistant overband or surface treatment is very important to us. And you also need to know whether it's going to be a flexible or a high modulus repair. And these can be applied at anything from 40 millimeters wide up to 200 millimeters. Here we see that's cleaning with hot compressed air to dry and clean the surface. Then a final screed with the hot or the cold applied resin material. Here's an example in Hull City. We carried out a range of crack repairs here. This is on a lean mix subbase. There was two types of cracking occurring here. There was reflective cracking and also fatigue cracking. You can see that was inlaid. That was a two-part system. So we laid material in the base and then topped that with a flexible braid of material, which helped to withstand the action of traffic. Typically an output of around about 80 square meters per shift would be typical for this type of treatment. So the key to successful specification of a crack repair, you need to identify the crack type of crack that you've got on the carriageway. the correct specification of the system, whether it's an inlaid or an overband system, the correct grade of material, whether it's a low or a high modulus repair, specifying the crack width. Again, I would reiterate, specifying the repair width, not the crack width, and specifying the depth of repair needed as well. Also, you need to make sure that it's an approved system that you're specifying. And correct banding of quantities. We often see the banding of quantities in your tenders that you send to us are too low in quantity, so 0 to 50 linear meters or 50 to 100 linear meters. We're treating something that may be in excess of 200 to 300 linear meters, so a sensible banding of quantities is ideal. That's me. Is there any questions?
So nothing from the floor. I've got a bit of a question around the milling.
Yep.
I've seen this type of system used in applications. I've not seen that milling before. Do you do that for all your installations?
No, not only where the repair needs to be an inlaid treatment rather than an overband. So it's typically where there's multiple cracks that needs to be treated. We may be going maybe 40 millimeters deep, and we need to then mill that out into the road surface.
We've also, certainly in Cornwall, we're using more of these kind of masticky treatments for wider defect applications.
Yep.
Is there anything you can tell us about your products that might solve that?
Yes, certainly. A crack repair is very much a targeted response to a surface defect. And the repairs, so the inlay repairs could be of any width and any depth. So typically they may be sort of 200 to 300 millimeters wide. We do have other materials which are screed applied surface materials. Those have a use. However, being a very thin layer, I would question as to whether they will effectively repair the crack long term, being so thin with movement that's likely to occur.
We've got just a few minutes, so it's a bit of an interesting discussion, I guess. My observation of the modern materials is that they fret and they fail in a different way than the old traditional asphalts.
Yes.
I'm interested in that application about sealing that surface at the early stage and the application that...
Yes, certainly with things like SMAs, there's a tendency for them to fret and ravel, which is why we see a lot more of the surface lane joint deterioration, that kind of thing, on roundabouts. Certainly these the surface applied materials are very resilient and will withstand a lot of traffic, certainly on things like roundabouts and areas where there's a lot of friction. I mean, you can go wider with crack repairs. We're very much about targeting it to that particular location where the defect is. That obviously saves you money in the long term as well. So,
okay, Tony, thank you very much.
Sure.